already have it. No, it's Arch. Not that you can tell from looking at my screen. Yeah, but I mean, a distribution is, in my opinion, just how you package the packages. For the rest, everything compiles on every distribution and runs on every distribution. I just like console. I don't even have KDE. I can imagine that what's important is that I have X windows running. Well, for the rest, it will just work. If I would have like a Wayland or something, and you need a recompile maybe, or anything that displays stuff like console would. Well, there is a library, I think, that mimics the API of xlib or whatever the library for X is. It translates that into Wayland stuff. This function is nothing if other refers to the same object. Otherwise, it merges other into this. Both lists should be sorted. No elements are copied. And the container other becomes empty after the merge. So it sucks in merge, so it sucks in other, I mean, and then okay, zips it into the current list. Okay. See what it made. Yeah, it wrote all of them, calling merge other comp. Yeah, because there's not really a difference between the R-value reference and the normal reference here. Other ends are empty anyway. So even if you pass it as an R-value reference and just pass it to just call the other implementation, right? And then if you don't pass a comp, it's just using standard less on T. So comp must be able to compare T values. That seems to make sense to me as well. However, it's using splice. Maybe I should implement splice first. I don't think that the allocator is doing anything. It's like explicitly saying that no elements are copied. See, the elements are untouched, basically. No iterators or reference become invalidated. So this should be part of the base class and not part of the list, because it has nothing to do with the allocator. Otherwise, I agree with this. And then let's see this. Okay, so it does nothing if it is equal. First begin and last first two, other begin and, well, first one is unequal last one, and first two is unequal last two. If comp first two, iterator next, first two, increment next, splice. This is typically something it should be able to do, because this already exists and you can find it on the internet. So I'm gonna assume that this is just working. Maybe you should test it though once. What I do want to check, however, is the fact that it says that it was stable. Equivalent elements in the two list elements from this always precede elements from other. So let's say that they compare equal. Well, this is like less than, so equal means that this is false. So the current list is traversed first, or do I miss something here? Yeah, it eats all the equal elements, and then first we go to the next element. So then first becomes larger than it was, at which point this one is less than that one. So we just don't touch the elements in the current list until we run into an element that is actually larger than the one in first. Now, what is this doing? I'm afraid I don't know how splice works. It's a bit hard to check then what this is doing. But it definitely looks like first two is incremented by 1. So I guess it's inserted. Yeah. So this should insert other. No, that's a list. It should insert the element pointed to by first two, element of other, after first. It really depends on how splice works. Let's just have a look at it. Did it look like this one? Pulse other iterator. Yeah, single iterator. Transfer the element pointed to by it from other into this. The element is inserted before the element pointed to by pos. So that's not good unless... Oh, wait a minute. Pos was first. Yeah, pos is already larger, so that is actually correct. So incremented first until it became larger, and then we inserted before the larger thing. And indeed, it's doing that in the same order. So it keeps the order of the elements from other as well. And then one of them reaches last, then what? Okay, so if this is true, then we just inserted everything and we're done. And if this is true and the other one isn't, then there are elements left in other which then have to be added to the end of the current thing. And I guess then last one should equal end. The last one is end. It should not even changed. So if this is true, though this is true, and we left it, then this must be false, which means that first one must be equal to the last one, which is equal to end. So last one is just end here. In other words, it appends the remaining elements in order to the current list, which is correct. No, okay. I never used merge in my life, so I don't really care if this is false or not. It seems to work. I'm just going to add it and be done with it. Except that I want it to be part of the base. I don't think the splice changes first too, does it? Go back to splice. No. It's passed by value, so it can't change it. So I have no idea why it's doing this. Why make a copy? Let's see. It makes a copy because first two is invalidated. But it said no, it said that nothing is invalidated. No iterator reference become invalidated. So first two stays valid, which means that you can just do plus plus on first two. We don't need this at all. No, they don't like to use braces when they are not needed. This is also bullshit, but I just do that. AI unlikely. Consider a documentation. Like this is really normally not happening. Yeah, and using new variables for these two is a bit dubious, but well, okay. I like to add a const 0 just to show that they are not being changed. And then all of these should be inlined, because it's of course almost doing nothing. So this is removed, and then, well, they are void, so that's okay. We can already indent them. The allocator is gone. Must be list base. And then list doesn't exist yet, so this must also be list base. Is that possible to just use list? I'll try that. And it must also be a list base then. Yeah. All of these are a bit, I mean, this is protected, and this is just my iterator stuff. Node cost, static functions, the value type. Oh, here they are. Yeah, public functions. So I'll just put this at the end of the list of public functions. And then we need to add the other. I need to add the other merge. So we just added this one, and this one has to be moved up as well then. Yeah, these things should also be inlined. let's see, this is a free function. This is already list. Yeah, so probably should put it's all member function of list. Except this one, so I'm gonna move this one up till above the others. Let's put it below swap, I guess. It's the first free function. And then all of these, oh wait a minute, what is this? That's also list. Oh, I got confused with the free function. Damn it. Guess I can do an undo, but maybe not. Delete my merge. There's the swap. So all of these I want to move into the class, so they are always inlined. Could mark them as inlined here, but yeah, maybe I should do that, but I don't know. Let's just put them here. Okay, now I'm not sure anymore. They are marked as inline. I think it's a value type thing. What did I just remove? List-based value type. Oh, it's implementation of value type stuff. Yeah, maybe that should be here. Because otherwise the list base itself is incomplete. I could try it, but yeah, well, just put it here, I guess. They are inlined. Okay, so that was a merge. Just check if it compiles. It compiles. Okay, shall we test it? This one thing, just, you know. I hate testing, it just costs time. I'm just going to make a very simple list. So in my list type, I'm going to use something else. Just ints. For example, so utils list of int. Extremely lazy to copy this. Well, they must be sorted, yeah. So oh, you must be confused, cat. Seems pretty not really testing anything, if you ask me. Well, we have 2 4s and we have a 1 extra 3, just one. Yeah, okay. Oh, I could have copied this. I'm such an idiot. sort. Yeah, I put them sorted in because I didn't implement sort yet. I need to be able to print them. Okay, so we're going to print just the result. Copy. And then I must be able to print it. For const int, interesting, but int fails to be a struct or class type. Oh, this gives me value types back. What? Oh, we can't do this. You can't derive from int. To fix it, if I can put it here, T stuff, but that does reorder. It puts a note really in front of it in T, which I wanted to avoid. But I don't have a really good reason for it, so yeah. And that's why it has to be down there, the definition. This returns an iterator, or a const iterator, which needs the definition of value type. Otherwise I would put it inside node to begin with. Seems like previous and next has nothing to do with value type, when it nothing to do with data anyway. But I want my iterators to be aware of this class, apparently. Maybe it can be an incomplete type though. I don't think so. I mean, the type must be defined inside the iterator. Yeah, and maybe it's an incomplete type is good enough. It could forward declare value type. It is a class. And then define iterator, const iterator and iterator. And then define value type. I'm chasing too much at the same time now though. Okay, let's do then this afterwards. I'm first going to yeah, let's not use int, because that doesn't work at the moment. So I'll just use data anyway. Not sure if that works. Data must now be constructible from an int. Maybe I should just use something else. Int, there we go. Data. Okay, so we have a struct int. Just for the bloody test. Yeah, we need an operator less for this thing. By value. And I need to be convertible to an int. And it needs to be constructible from an int. Probably need a default constructor, maybe. And we need to be able to print it, but we can already print it. It will just be converted to an int. Do this compass. You got to be kidding me. It's still doing list base int. Quite from here. What the hell did that come from then? List base int? No. Oh, here. Yeah. Duh. Okay, so we want to be able to print list int. Could make this a template, but could make this a template. Well, theoretically, I guess I should use const reference here. Could not convert from brace and close initializer list to it was list int. Yeah. Probably need to allow construction from an initializer list then, right? Instead, initializer list int. Oh, wait a minute. Now we're talking about... no, that's nonsense. This gets more and more annoying by the minute. Templated constructor will work, Otto says. Why not int? I mean, I can already create it from an int. It just doesn't want to initialize the elements like this. I mean, it will work if I do this, but it's a lot of typing. Yeah, list. What? I don't even have an initializer list here. We don't have the what? Okay, now I'm very confused. List bleep constructor. I clicked on it. I really did. Initializer list. It seems I'm missing all my constructors, including this one. Yep. Okay, that's surprising. Default constructor. Well, at least we have that one. I think I'll do just this then. And call this one default. And then we have an explicit just allocator. There is none. Oh, here, explicit list const reference of the allocator. Yep. That was the second one. Then I have a copy constructor, which is, I guess, this one. There's also one where you can copy construct but use a different allocator. Oh, I really hate to implement that. And you have a move constructor, and then the same shit with the allocator again. That is 8 and 9. So that doesn't say anything about not throwing. None of these things is no accept, is it? Are they? Move constructor? Why would the move constructor not? Why would the move constructor be no accept? I mean, a no accept comes from the AI. So I guess I'll just delete it. Of course, yeah, I don't see it here. And then also with allocator. And then we just start at the top. We don't have this one yet. Oh, until, damn it. And here it is the same, that is gone, and the explicit is gone. The rest looks the same. Allocator value, okay. Until 0 plus 14, since 0 plus 14. And then finally the one that we need. An initialized list of type T. Init default allocator. And then I want to implement that one. Yeah, this is just, we can just implement this one in terms of this one, right? So we can kind of inline this. Whoops. So list and then just init begin, init end. The base class, and then we have elk. From elk. So then we must implement this one. Yeah, now we have to append stuff one by one, because the stupid allocator is working like that. And all the begin or all the previous and next elements have to be initialized anyway, so yeah, you just have to add them one by one. And if I append this, so they now inserted before end, then end previous has to be changed all the time, which is not very nice. Because that one, I tainted that one. Probably better to append it. Sorry, prepend it before the first one. So if you do this in reverse order, then it should be slightly faster. To do the add the first element. Something with create node, push back node, to resize, push back node. This has nothing to do with the algorithm. Well, I'm going to use a list for that, of course, but the title has been like that for half a year and I'm just too lazy to change it. Right now I'm implementing a doubly linked list with certain special traits. I guess I should or can use pushback node for the first one. No, I should just call this function maybe. No, wait a minute. We have a pushback. Create nodes and place back. I think that see and place back. I can just call and place back. It's the most direct thing. That we just created and then call pushback node, which is what I want. Now we're gonna ignore the return time, but yeah. So I could call pushback, which then calls and plays back. It's on as inline, so it's kind of strange to do that. I suppose I'll just call this. And then that is the first element, or rather the last element. The last element first, however, last is the one that should not be inserted. So you have to decrement last first. I'm gonna make a current, I think. Current. we don't want to do last. Last might be end even. You just decrement it, and then it points at the last, the actual last element. And then we place that back. It might be slightly slow. And then we do while current is unequal first. Because it wasn't at first, but now we have it decremented, it might be equal to first. And if it is equal to first now, after one decrement, and first is the only thing that we wanted to have inserted, and we just did. So while it's unequal first, we can decrement current again. And then insert that one as well. But now I'm not going to use in place back, which is microscopically slower because it's using pushback node, which calls untained and tained, which is ridiculous to avoid. I have no idea why I want to avoid it, but I'm just such a speed freak that I can't get myself to do that. It's the whole reason why I'm inverting this loop in the first place. So now I could use insert node, although I'm not even happy with the fact that it increments size every time. Seriously? No, I have to count it anyway. We don't know how large the loop is. So calling insert node would be reasonable, I guess. You first have to create it, then I could call insert node. Can't get any faster than that. The rest is extracting. So now we have to create a node, which is, can steal that code from here. I'm gonna do that here already. New node. Create node, send it forward args, but we just want to create a node from. Oh, from what? From this thing, of course. The current pointer. Oh, no, we have to do that first. Oh, actually, now we can combine it in one line. Pre-decrement. And then I call insert node, which is void, and then we're going to insert before pos, comma, new node. So before that one, new node. Could make that one line again. Why would I declare new node? Anyway, we have to insert it before the current value of last. Well, I could do that, but then we have to run in the other direction. So, what am I doing? I don't know. I just want to. I think I want to. Wait a minute. Insert node. Yeah, it takes a const iterator. Well, I think I want to use the last here. So it seems to make sense. So then this loop changes. It becomes actually current equals set current to first, while current is unequal last plus plus current. Let's then create node current. How about that? Last is one past the last element, so we do it's not empty, so we can decrement it, and then we point to the only or last element. Never add something that doesn't exist. And we place that at the end. Which updates, for example, it's in place back in empty list. So this called pushback node, which deals with taint and untaint and stuff for the base node. And then we insert the rest, just starting at first, all the way up till, but not including last, which was already in the list. So all other things are now inserted before last. Insert node increment size and in place back also, of course. Mim initializer for utils list alloc follows constructor delegation. Oh, it is not allowed. But there is no constructor that actually there is a constructor. I think I just passed allocator here. Okay, so boing, boing, boing. Where's the enter key? I just have to pass alloc to this one. It's a nonsense what I did, indeed. Declaration of different specifier. Yeah, I think I removed the no accept. It's probably the thing, right? Apparently it was. List 1 was not declared at this scope. Yeah, I call it a lie 1. And list 2 the same thing, because I was too lazy to look further along the line. And it still doesn't work. Wait a minute, what is this? In instantiation of the one that I want to use, indeed, with input iterator is an int pointer. Okay, yes, so that seems to work. T equals int, allocator is the standard allocator of the utils list base int value type. Required from standard initializer list thingy. Blah blah blah. There, required from here. Error, insert node was not declared. Oh god. Wait, create node is part of this object. I mean, not part of the base class, right? Cannot convert int const pointer to utils list base int const iterator. That is here. You're telling me that last is not an iterator. Apparently. Oh no, indeed it isn't. Oh. Oh yeah, well, okay. So a place back is returning an iterator to the just inserted element, isn't it? So this is going, I can make a const iterator and place back. This thing is not const. Might as well use iterator. I want to call it last. I just want to. Wait a minute. That is current. That is this, but this is last element. Still doesn't work. Conversion from value type to non-scalar type. That's strange. Oh, and place back returns a value type. Oh shit. I can't use and place back. I'll just use insert and. So. And place back. Returns a reference. Yep, so I guess we have to use insert. That's kind of strange. I thought I implemented insert in terms of and place back. And you can use this one. There is no insert back, right? Getting desperate here. No, it's not. So insert before the end. Yeah. It's sad but true. You know what? I'm gonna call it back. I'll say usually they call that back. Well, back is then a reference, so in this case it's an iterator, but okay. Or no, let's call it last element. Help. Oh, this looks so dirty. There is no way to insert something at the end and just get an iterator to it. Or shall I just do I'm just gonna do and place back and then wait a minute, and then initialize the thing on a new line. Well, that is begin at the moment, because there's only one element. Yeah, that looks good. Okay, and then instantiation merge. Splice was not declared. Oops, we didn't implement splice yet. That is didn't implement it. It says it's not even declared, which is strange. It should be declared. I think this is also a problem of base class. It doesn't even have a color, but it would be the definition. So splice. I put splice here, which is it's just in list. In list still. I think I should move the splice to the base class though. Very, very, very likely. Just begin with doing it. Iterator list or reference. This one exists anyway, and that's a new one. Okay, so both const iterator, all of them. Zip. And then we have list other const iterator it twice, and I'll arrange first and last also const iterators. This is good. Oh, the reason is that I moved them merge to the base class. Yeah, so this is fixing it. This is fixing it. It didn't exist in the base class. Is it a problem that I use the base class of the list in the? I mean, now my declaration is no longer equal to what it should be. It explicitly says here that it must be list. And if I move it here, there is no list, so yeah. I just use a list base. Well, screw the standard. And then we have undefined reference to splice. So we have to implement that. Claude to the rescue. Thanks, please do the same for splice. Well, those are big implementations, and more than one. I'm not super happy with this. I must say I'm impressed with that it knows that it must change the base node previous. It's kind of impressive. And maybe it even figures out the logic or when to do that. But I'm going to copy this bit by bit, I think, and then check it and think about it, and we have to put it rather high. These are in line, so we do those first. And I have no idea why I would do swap first, actually. This is still list stuff. Merge call splice, so let's do splice before merge. And then just move this one down to its own list. So we only have one of them. Okay, so what should this thing do? This is boss list other. So number 1. Transfer all elements from other into this. The elements are inserted before the element pointed to by boss. The container other becomes empty after the operation. Okay. I think I want to use an extract. Extract the whole list. Extract range. So we just pass first and last equal to the whole list. Then last equals base node. So really we just want to do this then. This, yeah, might as well just mean really. This just empties the list. Return base node, that's not useful. Move range returns the last element removed. So this is not good. This is not true. What the fuck? Actually, it is correct. We just have to use first to access the elements. So this empties the list. And then afterwards we can run from first to the return node. It should be visible in wherever I use it. Yeah. So it is run from first till the last extracted, which is returned. But then that's not really necessary. We don't have to do that. This also doesn't look correct. Why is the base node next not set? Oh, this is because you call extract front. Probably. That sets base node next. Yeah, I guess it doesn't matter what it comes after pos. This is the list of other. Where other begins stands for the first node of other. First element of other. I'm not sure yet what happens if the list is empty. So if the first element exists, then that has a next pointer which points to the next element and so on until finally we get to the last element. This might also be the same as begin, which then points to the base node of other. And this one is simply we have some element that is before pos, which has a next pointer to pos, and pos previous points back to that one. And we want to end up with that this thing now points to the first element of other, which again points to simply all the rest. And then at the end, the last one must now point to the base node of the current object. And that is nonsense. It must point to pos, which I have done in a horrible way, like that. This points to pos, and pos previous points back to the last one. So now all of them are inserted before pos. I think that's correct. However, we extracted the nodes. So instead of other base node, we should use base node. Although I didn't change the next pointer, so I just copied the base node. So this thing still points to the base node of other, but we're going to override it anyway. Of course, we have stuff that points back, which also must be changed, doesn't it? A minute. This thing has a previous that must be changed. So where does that thing point to then? Well, we can start with just giving the whole node. So I did make a copy. So we have base node dot next. That is pointing to the first node. And the previous is actually pointing back still to this one. So didn't change that one, didn't update it. Okay, now the base node previous is tainted and we need it, so I could write an untaint around it here. Before it's actually pointing to something. Now, can you implement it, I suppose? So we only need to update the current list. We're only concerned with that, but also I have to update pointers of these objects. But that would only be this one, of course. and that one. And yeah, and this one and that one. So this just, we need to update 4 values. That's it. So I'm gonna have a node pointer pos -1, which is pointed to by pos previous. Well, then the question is, must be untainted? Can pos be end? Splice, so this inserts other before pos, so pos could be end theoretically. So just in case, I have to untaint this thing. So this must point to other begin, which is pointed to by base node next. That was this one. I don't know what to do next. Let's do this one next. Yeah. So then we need other begin. And other begin is whatever this thing is now pointing to. So this is other begin. So other begin previous is the value of this pointer, and that must point back to pos -1. It's kind of the typical way that this stuff is inserted. So first you do next, and then you do the next previous, and then this line is like standard. XYZ next previous is XYZ. Fixes the previous. And then of course previous, if previous is the base node, or if this is the base node, then the previous must be tainted. So the question is, is it possible that this is the base node? Thus, is it possible that this is the base node? And that is possible only if the other was empty. So if other is empty, then the base node next points to itself, which then means that in this case we have to taint it. No, wait a minute, this is pos -1 must be the base node. So that is only the case if the current list is empty. Okay, again. So when is this the element of the current base node? That is the case if this points to the base node, which was just assigned, which means that this must point to the current base node, which is never the case, because no. I mean, at most it's pointing to the other base node. So this would be totally wrong if other is empty. So other cannot be empty, otherwise it won't work. If other is not empty, then base node next is just the first element. It's an actual element and not a nonsense element. Yep. Guess this is the list base. Yeah. The taint is that I set least significant bit in a pointer. So pointer is usually, or these pointers are definitely aligned to other pointers. So they are aligned to 8 bytes, so the last 3 bits are always 0. And a taint just means that I set the last bit. So it is doing OR with 1. And untaint is remove that 1 again. So it's just 1 clock cycle. It's not even accessing memory basically. And still I'm trying to avoid it. Complete idiot. But yeah, well, you have to only write it once, I think then. And then it's done, right? So why not put a little bit extra effort into it? The only pointer that is tainted is the base node previous. And the reason is that I can recognize this, that node is the base node. Hello, silence. Pulse -1. Okay, well, I think updated these 2 pointers now. So now we have to update these 2 pointers. Which means that again we want to find that one, and then we can just fix this one as well. I think so. Well, rather you have to find this one first, and that one is this one. So do the same thing. I just need to make a new variable for clarity. So that is other lost. Which again is not equal to the base node, because it's the last element in other, and other is not empty. Do I really have to repeat it? Okay, and then we want to set I think I set this one first. It's time to go to bed. Yeah, you're right. Yeah, I should go to bed. It is 30 minutes to 11 p.m. But I can't afford getting to bed till later for the next week. I should have stopped at 10 p.m. Let me just finish this splice and then I go to bed. You must be in India. Is that correct? What India? Am I confused, or is it just, is India indeed plus 3.5 hours? Actually, it's more than that. Oh, India is plus 3.5, but you will. Well, yeah, you added. No, it's 48 here, so it can't be 30. I think you counted from my. Yeah, this is 3.5 hours. It keeps me motivated to code for a long time. Well, I don't need motivation. I'm just coding. I don't think continuously about anything else in the code. Yeah, I don't know. Maybe I'm good at concentration, but I'm so into this that I'm not thinking at all I want to do something else, or for how long shall I continue, or I'm feeling tired, shall I stop? I just don't think anything like that. It's just not on my mind. The only thing on my mind is the code itself and the problems in the code. So time flies by. I don't know, why can't you code for too long? What happens? What's the difference between the first hour and the second hour? If you don't keep any track of time, then there is no difference. Why would the second hour be different from the first hour then? Only because you realize that you already coded an hour? I have to stop, already coded an hour. Well, I don't get distracted. I'm in the house alone with helicopter anti-sound headset on. It's completely silent. 100% completely silent. Curtains are closed. No distractions whatsoever. And also not in my mind. The only distraction that I have, which is extremely annoying, is the chat. The YouTube chat. You are distracting me. Yeah, I'm getting really, really old. Really old. It's not much fun to realize that you're this old. Yes, you're distracting me. I want to finish this function and I have to go to bed, damn it. Post previous is nah, I'm just mine is pretty bad, I agree. Yeah, you're right. Kotaro is always right. I must say I don't really like this format though. It looks like a C cast. Is there not a better way, like doing it like this? I thought I'm just going to do an undo to jump back where I came from, but no. No, I can do that. Undo, 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 undo. And now 526. Redo. 526. Shift G. So now I'm back. Okay, so post previous is, well, other last. That was easy. And then we have to set other last. So I'm just going to copy this now. It's kind of ridiculous, but hey. I want it to look like that. But, no, wait a minute. Other last is not base node, so this previous does not have to be tainted. So we are finished. No, I'm testing everything at once after the whole thing is finished. I'm going to look for a existing standard list or whatever, a doubly linked list test suite. Probably doesn't exist. I'm going to ask the AI to write a test suite for me, I think. There's going to be such a ridiculous amount of work just to write a test suite for this. I really don't want to. It would take me another 4 days. So this splice is now finished, huh? Yes? Yeah, I mean, I just, not all at once. I mean, we just need a really big test suite. And I don't want to write it myself. Because it's really big. It's, like I said, another 4 days. Assuming that I can even finish this in 4 days. It's already day 3. Tomorrow I can't code either in the evening because I have to go play chess. So in real life. Now what the fuck? Oh, pos is not a node pointer. How many poses do we have? I need a pos node. Node pointer. Pos node is pos pointer, I guess. And then we can use pos node. Pos minus 1, blah blah blah, pos minus 1, blah blah blah. Yeah, pos node previous. Pos node. Still is a splice missing. Let's see which splice is that. Const iterator. Const iterator. Iterator or iterator. Oh, we did a whole list. So the other one is this one. Can implement this one already. This is just error. So we have to write this one and then this one as well. And the R value references we can just call the L value references implementations. Right, pos order first last. Actually, we can implement this one in terms of that one. And if I had paid any attention, I could have implemented that one in terms of this one. That's probably what I should do. Just implement this one and then the rest calls that. AI did it again. It wrote many functions. And then I thought, well, it probably has a point, and I just picked one at the top. But really, we should have started with this one. And the rest can be implemented in that, I think. Yeah, of course. I don't want code duplication for functions that I never use myself, like splice or merge. Implement this. Okay, I go to bed. Good night. Simple robots. And sounds interesting. If I stop the stream, the chat keeps working for another few minutes. So join Discord if you want to keep contact, people. I'm sorry. I have to stop the stream. I want to go to